Tuana. I am also Turkish and live in the Netherlands. And I am a developer relations engineer here at Weaviate. And I've been around since November, I think. And yeah, today I'm going to talk about the Weaviate Query Agent that we just released for everyone to preview. JP, why don't you introduce yourself then?
I will, yeah. I work. My name's JP. Work in the same group as Tuana. Working at Weaviate as an educator kind of role. Been at Weaviate just about a minute, a couple of years. And for the purpose of this session, I'll be mostly just helping out and moderating and so on. So if you have any questions on chat, I'll try and answer them or pass them on to Tuana as best I can. So I guess that means I can hand over to you, Tuana, to get us underway.
So this is mainly meant to be a bit more of a hands-on session. So I'm going to briefly go through some slides, but the main thing that we're going to do is then walk through the recipe that we released alongside the query agent. So first we'll start by covering what the Weaviate Query Agent even is. Then we'll have some live coding, and then I put Q&A at the end, but I feel like, yeah, JP, feel free to jump in and forward me any questions if any does come up. If you are interested, we released the Weaviate Query Agents in the beginning of March, and this QR code should take you to the announcement for that, which gives you a lot of details as to what the query agent even is. But don't worry, I'll also be talking about it now. Because what we've built is, very simply put, an agent designed to be given access to your Weaviate collections, any collection that you would like it to have access to. And the query agent can then, given a user query, it can decide which collections it has to access to get to the answers to that query, as well as what kind of searches to perform on it. So the way I kind of like to explain this to myself is, if you are familiar with the concept of AI agents, and if you have any questions about them, please shoot, because I love chatting about this topic. But if you are familiar with agents, you can think of the Weaviate Query Agent as an agent where the tools are the Weaviate collections that it has access to. So instead of making any decisions about what kind of searches to do ourselves, you are able to now hand that over to the query agent, and the query agent uses an LLM to then decide which collection or collections to access. So you can basically say, Weaviate Query Agent, please take the wheel and do all the searches that I might need to answer my query. So based on a query, if I were to summarize what's happening, what happens is the agent decides which collections that it has to have access to, or it has to access to answer the query. The next thing it does, which is pretty neat, it decides whether it has to do regular search to answer the query. So think of this as semantic search, whether it has to do any aggregations, and I'll briefly discuss what we mean by that in a bit, or whether it has to do both. It then formulates, and this is really neat as well, because it may end up deciding that it has to perform multiple searches to answer a query, but it will then also decide what query to forward to each search. So it may break up a complex question into sub-questions and forward those to different types of searches. It will also determine filters if needed, and we'll see an example of that in a bit. And then finally, based on the results from all of these searches that it may perform, it then provides the user with a final answer generated from all of the sub-answers, if you will. And why do we have search versus aggregation? And this is how I sort of, again, explain it to myself. While some queries are resolved with regular semantic search, some are not. Some queries are more similar to actually an arithmetic task. So think of it as, maybe some queries require you to count things. Maybe some queries require you to find the minimum or maximum of things, or average of things. And we need to send Weaviate a very specific style of query to get to the answer of those types of queries. And the Weaviate Query Agent can also handle this for us. And we'll see some examples of that in a bit. So what we're going to build, oh, something happened to my line there again. I thought I'd add it. What we're going to build is a eCommerce agent, using the Weaviate Query Agent, which will have access to a data set that contains a bunch of clothing items, the pricing, etc. This is the eCommerce collection, and another one that has access to information about different clothing brands. And this one is more like, where does the brand originate from? Does it have any child brands? Does it have any parent brands, etc.? To get started, we need to install the Python client. This is for now only released with the Python client, and it is only available to Weaviate Cloud users, but also free sandbox users. So if you do want to get started, make sure that you create at least a sandbox with Weaviate. Once you have that, then you can go ahead and start using the Weaviate Query Agent. And the only thing you have to be aware of is that there are some rate limits for now. But without further ado, this is where you wish me luck, because we're going to start with the coding part of this session. Is the font okay, or should I increase it?
I think it's okay. Yeah. Let us know, please, in chat if you think that's too small. We can probably go one size larger.
Okay,
just to
let's do
be,
that.
Yeah.
I see some messages in chat, so do let me know if there's any questions that I can answer already.
Thanks. Yeah, so far so good. You actually answered it already, because the question was, is it only available on Weaviate Cloud? And the answer is yes.
Yeah. But like I said, you can also just go and create a free sandbox, and you should still be able to play around with this. So disclaimer, I also have the same recipe open up in this tab. So if anything goes wrong, we will get the outputs there, because I have not removed the outputs there, but hopefully it all goes well. So to get started, maybe JP, you could send over the link to this recipe for people as well. To get started, hopefully this is already installed and I don't have to install it again, but we've provided you with some demo data sets. So like I said, we have the eCommerce data set, and we have the brands data set. If you do want to take this recipe forward and build some other types of agents as well that has access to completely different types of collections, we also have a bunch more. For example, we have a data set called financial contracts that lists a bunch of financial contracts, a weather data set, and so on. But those are just extras. For our demo use case, we only need the eCommerce and brands data set. Then we go ahead and install our client. I don't need this because I'm now using, hopefully this works. Let's try. And I go ahead and connect to my Weaviate Cloud client. And here I have a bunch of collections, and I'm just simply going to be using the eCommerce and brands dataset. The way I've done it is I've just added the keys to the Colab environment for now. If you do want to start off with the data sets that we've provided, you would then go ahead and run these code cells as well. These will create for you collections called brands and eCommerce. And the one thing I do want to point out here is the description of the collections. So the descriptions, as far as I'm aware, JP, correct me if I'm wrong, has been a feature that's been relatively underused, but now it becomes very, very important and useful for us. So when a query agent will eventually receive a query, it has to make a decision on which collection may contain the answer to that query. And this is where we make use of the collection descriptions. So when we start creating collections in our Weaviate Cloud sandbox, we then have to describe what the collection is so that the query agent can decide whether it's useful for any given query. So here I've added a description for brands. which says a data set that lists information about clothing brands, their parent companies, average rating, and more. And also e-commerce, a data set that lists clothing items, their brands, prices, and more. You can get a lot more detailed than this if you like. You can also experiment with it and see if changing the description helps you optimize the results as well. I'm not going to run this because I actually already have the collections ready in my Weaviate cluster. Next, you can again run this. All of our data sets are available as open data sets on Hugging Face. This will then go ahead and write the content to those collections you just created in Weaviate. But now we get to the interesting part. So like I said, the query agent, if you are familiar with agents, you can think of an agent where every tool is a Weaviate collection. So to initialize it, we simply have to import the query agent, provide it with our client, and then we have to provide it with a list of collections that this is able to have access to. So this brings me to one other requirement. As you can see, we are connecting to a specific client. This means that the agent can be given access to any collection within the same cluster. In my case, I am providing it with the e-commerce and brands datasets. And hopefully that worked as well. And then next, we want to run a query. Running the query is pretty simple. And in this case, I have a question that should ideally only have to access one of the collections that we have access to. The question is, I like vintage clothes. Can you list me some options that are less than $200? The query agent, once we run it, it returns a response, which is called the query agent response, which includes a lot of information. It includes information on which collections were accessed, which types of searches were done, what kind of filters were added to the queries, and so on. So we do have a helper function, which I really like, print query agent response, which I'm going to be heavily using. And this is where you cross your fingers for me. And let's hope it runs. That's where we wait.
Yeah, and it's really cool that, instead of having to formulate the exact Weaviate queries, remember the syntax and so on, you're kind of asking it in natural language. And there you go. Looks like it's worked.
Yeah. So this helper function actually prints it out in a pretty neat way. So I get the original query, I get the final answer, and we can maybe visually just go through this because we did say that we wanted vintage clothing less than $200. So I can see that the pricing here is less than $200, which is great. But the more interesting thing is inspecting what kind of searches were actually done. So we can see that we forwarded the query vintage clothes to the e-commerce collection. But most importantly, we've also added the correct filter to our query. We had a $200 price cap. And so we can see that the price was set to less than $200. At this point, I've just realized that there's something that I kind of glossed over. So I can maybe point that out as well. Because when we're creating our collections in Weaviate, the same way we created descriptions for the collections, you can also add descriptions for each property. And this is something that I had done retroactively, creating the recipe, because the price property didn't specify the currency. So I later on added the description to the price property to say prices in USD. So just so you know, if it makes sense, it's always useful to add descriptions for each property as well. There were no aggregations. We can also see exactly which objects from what collection was used to formulate the answer. And we also get some statistics as to what the query or how the query was generated.
Hey, that's really cool. I've got one comment myself, which is like on the helper function, if you scroll up, where in the cell that we ran, I think we added a method. So I think we might be able to just do response.show, the response dot, sorry, display. Can we try that? Display. And then run that as a function. So I think,
Like this.
yeah, I think if we do that, I guess it'll rerun the whole query. But maybe if we run that on the next cell or something, that'll
Yeah,
just
that's a good
run
idea.
the print query agent response as a method. So you don't have to import that.
That is amazing.
That's my one contribution to code base. Um, So yeah, so it's the same thing. But it's just the exact same thing, just implemented as a method. I've got a couple of questions. I wonder if it's worth sort of discussing some of that now before we go further, if you're up for it.
Yeah, yeah, let's go.
Cool. So one question is about um, I guess some of the questions I can think of categorizing as a theme of how organized does our data have to be to do this, right? So one of the audience members is asking, hey, what happens in a use case where we don't know where the documents go in terms of collections? So that's one case. So like their end users might drop documents in relation to particular like business related, what have you. But they
Hmm.
don't have a great um, heuristic or some sort of taxonomy for organizing each one into a collection. And then so how would that work? So that was one question. And then kind of a related one was how clean or how organized does the data have to be for the query agent to work well? So quite interesting.
Yeah, the first question, I mean, I have an answer instinctively, but I'd be curious to see if you would agree with that. In this case, if we don't really know exactly what kind of data is going to be in our collection, um, number one, it might be in that case, I'm assuming that the query agent could even be something that has access to just one collection, which may contain a lot of things. And in that case, my instinct would be to describe the data set as such. The collection description should make it clear because the collection description effectively at some point is going to be used within the instruction prompt for the query agent itself. So that description has to make it clear that this collection may contain a variety of XYZ. And in that case, that instruction exists in the ultimate LLM prompt somewhere. And I think that gives it a good chance of knowing that this collection may be accessed for multiple purposes. Um, on the flip side, at the end of the day, I think ideally you have properties that sort of make sense, that can be described with, I don't know, some sort of unifying attribute. So for example, like very simply put, if I'm describing the price property in this particular data set as prices of clothes in US dollars, at that point, if I have one object that was listed with a certain price that was meant to be euros, at that point, yeah, I'm probably going to be providing it's going to result in some sort of wrong answer at some point.
Yeah.
Yeah.
Yeah, I think I agree with all of that. If there was a collection that just had a whole lot of unstructured data added by a user, essentially just free text fields, and then we ask the query agent to do something, I guess it'll just basically have to rely on semantic search to do its best to find the relevant
Yeah.
bits and pieces. But as you're showing that value property there, right, of 200 units, if you had data where those units are like, in Japanese yen in some entries and like US dollars in some other entries and like, whatever, the without annotation or like separate categorization, like the fields aren't going to be all that useful, much as it wouldn't be useful to a human if it was written like categorized that way, um, and and so on. So and in the same way that if the values were buried in the free text, that probably wouldn't be so useful either. Perhaps that's where, as a bit of a preview, something like a transformation agent could be useful to clean up our data for us. Um, but yeah, I think you're exactly right that the more organized the data, the better. But if we don't have that, we just have to really make that clear to the agent through by way of, I guess, the description which you mentioned for the collection and the prompt.
Yeah. I can also imagine making sure that I'll show it in a bit, but you can also change the system prompt of the query agent. So that's one of the more advanced things you can do. You can also make sure that your agent simply responds with, given my current knowledge, I cannot answer this, which is probably a better result than blurting out false information.
Yeah, I'm not sure how much I can help there either. But yeah, hopefully that's useful. If anyone has any follow-up questions on that side, please let us know. Speaking of follow-up questions, that's where we are, I guess.
Oh, yeah. All right, so now we've done one simple query. We've seen the query agent decide that it has to access the e-commerce data set. It did not have to access the other data set at all. It decided to do a regular search query. It decided to add a filter to it. Great. We also have a way for you to provide the previous answer as form of context to the next question. This allows you to at least somewhat have short-term memory while you're interacting with your query agent so that you can continue in a way the conversation that you had been having previously. So in this case, you can see that I've provided the context as the response from the previous query as context. And I'm asking a follow-up question. What about some nice shoes? Same budget as before. So in an ideal world, I can run this and hopefully it'll infer that my budget is still less than $200. And hopefully, again, it should be accessing the e-commerce dataset because I'm still not asking anything about brands. And I'm just going to do, you said dot display, right?
I think so, yeah, display.
Let's see. And we'll see if it formulates the right type of query. Next up, we'll also start asking questions that will require us to access multiple data sets. Okay. No shoes under $200. I'm not entirely sure that's exactly accurate, but it did get oh, yeah, I mean, nice shoes. Okay. Maybe it's decided that there are no nice shoes, which I think could be fair enough if we're doing semantic search. But we do have the right filter. Interestingly, in this case, I think it's also, oh no, it's fine, to less than $200 and the collection e-commerce. I have seen this for the first time. I'm actually quite impressed with this. So one other thing that our query agent response will contain, which is super useful, is if the agent has inferred that some of the information it has gathered is not enough, is missing context, it will tell us if the answer that it's provided is partial. And it will also provide us with any missing information that it has not been able to access. So in this case, it has decided that there are no specific options for nice shoes under $200. This is, I think, a great example of seeing how the query agent at each iteration is deciding the exact query to send over to search or aggregation. In this case, it was very specific in terms of nice shoes. It didn't look for vintage shoes. It didn't look just for shoes. And it decided that simply there was nothing listed as nice shoes. So it's decided that I can't actually find nice shoes under $200. If I were to rerun this, we could possibly see that it just decides to search for shoes and then say, okay, I'm going to look for shoes under $200. There are a few things we can do in this situation. We can play around with the system prompt to make it a bit, to narrow down the scope of how these queries are generated a bit more. But we could also then decide to rerun the query with the missing information provided as context and ask for the query agent to maybe reformulate the question and try again. All right. Next, we will try our first query that hopefully should access a completely different collection. So far, we've been asking questions that should be resolved by searching through the eCommerce dataset and leaving it at that. But now I want to test out if our agent can make the decision to search the brand's dataset instead. So what is the name of the brand that lists the most shoes? Actually, you know what? Maybe this isn't accessing the brand's dataset at all, because hopefully this is going to do an aggregation. I was looking at the wrong question. Hopefully this will ask for an aggregation of some sort and tell us which brand lists the most shoes. Oh my God, I hope this gives me the right answer.
No, I think that's right. And I think it might look at a different additional property, right? Because I think there's a brand property in the data set.
Yeah, I think I should have to rerun this though. I did not like the answer to that. We can look at the other
The perils of running anything that involves a language model, right?
I've not seen this do top occurrences again. Shall we look at what the previous one told us?
Yeah. But this is kind of interesting, right? Because as everyone, like as you all know, language models are somewhat stochastic. There's a bit of randomness. So there's a little bit of like rolling dice involved in running these models and things like that.
So this would have been what I would have expected. I would have expected an aggregation to be done with count, and I would have expected the maximum of that count to then provide me with the answer Loom and Aura. So that didn't happen, and there could be a few reasons for that. Different model, or simply just luck. But okay, I'm still happy that we got the answer is partial. The name of the brand that lists the most shoes is missing information in this case.
Do you think we have time for a couple of quick questions? Tuana, what do you think?
Yes.
Cool.
Let's go for it.
One is an interesting one about data set potential overlap, right? So what happens, Demetrius is asking what might happen if you have dupes in different collections. So let's say you wanted to search on vintage clothing. So you might have two collections, one for clothing and another one for shoes, or perhaps it's, one collection with duplicates. What do you think might happen if it finds, something that's in overlaps in those collections or some sort of subsets of collections? Do you think it might include, exclude those results? And how do you think that might deal with it?
It should definitely include them. And this is where the collection descriptions comes into play. And also, so for example, if your question is, let's say we have two data sets with shoes, clothing. They both have vintage shoes. One of them has vintage clothing, one of them has vintage shoes. And my question is, I like vintage items. I'm looking for vintage clothes and shoes for myself. What are some good brands? In this case, in an ideal world, the query agent should decide to do search on both of those collections separately. It will then receive answers from both of those searches on two different collections, and then it will provide you a final answer based off of those two answers. So in an ideal world, definitely that should not be an issue at all. And actually, we do have a question in a bit that will involve that will involve accessing, I think, even this one. Let's have a look at what this question is. Does the brand Luminora have parent brand or child brands, and what countries do they operate from? Also, what's the average price of item from Luminora? In this case, if this doesn't work well, we know something's going wrong with the query agent today, because it definitely worked great in the previous one. But in this case, I can tell you what has to happen. What has to happen is it has to search through the brands dataset to find out the parent-child brands of Luminora and what countries they operate in. But that, even though Luminora occurs in both of those collections, that particular brand's collection does not have any information on pricing. So it has to also then go and search through eCommerce. And this is exactly where the query agent should do really well. It should be able to decide not just one collection it has to access, but maybe to resolve a query, it has to access multiple collections, and then run those queries separately in parallel.
Right. And again, like you said before, the query agent knows what to do there, or it can make informed decisions about it because your description, I would think, has that information, like description of the collection has that kind of information in it, right?
Yeah.
That's really cool.
Is there another question?
Yeah, just really short one. Will there be any difference when you write shoes as opposed to writing nice shoes?
Let's have a go. I would say let's try it. What about some shoes, same budget as before? I didn't assign response to anything new, did I? I did. Let me just rerun this one because we assigned response to
That's right, because this is a follow-up query, isn't it?
Because it was a follow-up query. Yeah, I don't want to.
Yeah.
Imagine I hit the rate limit during this.
And while we're waiting on that, Rohini's asking here, we're not calling any LLMs. I can answer that. So we actually, I guess Tuana and I aren't calling language models, but the query agent does rely on language models at its end. So it's not calling them from, say, your account or what have you. It's the agent calling language models to make the decisions at its end.
Okay, so this worked. And it actually decided that this time I was looking for vintage shoes, which is actually a bit more accurate, because what about some shoes? I had asked for vintage clothes before. This is good. This is what I would have expected before. When I previously ran this query, the nice was kind of not considered. But apparently this time it very much was. So yeah, thank you for that. It definitely worked a lot better. And you know what? Let's just go ahead and try this one again too and see what that does. And then after this, we will run the query that is hopefully meant to, yeah, okay. So we're just apparently maybe this is something we can take back to the team, because we simply just completely do this top occurrences filter, whereas I would have expected the count filter in this case. But okay, it's just deciding to run the wrong filter in this case. Now let's try the query that is hopefully going to access both collections. And if not, don't you worry, we have a backup. All right, so I can already tell that this is correct. The average price is also approximately correct. Let's see. We have searched for the Luminora brand in the brands category and the brands collection. We've searched for the child brands of Luminora again in the brands collection. That's nice. And we've also filtered to the parent brand Luminora. That's also nice. Next, we've done another search. Okay, we've looked for the countries of operation in the brands collection. Then we've also, we've done an aggregation on the pricing. Hopefully this is correct. I can't see the right-hand side of my screen, but it seems correct.
Yeah.
In the eCommerce collection. And then what is our final answer? Let's go to the top. And I generated this data set, so I can tell you that this is correct. These were all of the child and parent brands of Loom and Dora, and it should be operating in multiple countries. All right.
Very cool.
So yeah, in an ideal world, in that for the previous question, something very similar should be happening. Even if you have information that's across multiple collections, the agent should be able to decide which ones to access and then provide you with a final answer. Okay. Are there any questions in the chat at all?
Sorry, just looking through some of the questions. There was one question about how well the query agent handle negation, which I guess would be a very open-ended question. So I think they're
That's a good
asking,
question.
yeah, and for those of you in chat, negation, of course, is adding, like find me, I guess, not nice shoes or not vintage shoes. If your question was like that, how would the query agent go about resolving
Shall we
that
try?
query and performing it? Yeah, I'd be interested to see that.
Actually, the not vintage is a good idea. Um, what about some shoes, not vintage? And then I'll just, so that I don't have to run the, and we
Maybe I'll
can
just
also
read the
see if it
context.
does well with a badly formulated question. What about some shoes, not vintage, 200 USD budget?
I think that's reasonably formulated. Oh, okay. I mean, I would expect that if you had properties that explicitly said how old certain shoe models are, or like, like a flag, basically, vintage, not vintage, it'll do better than if it has to run a
We
natural
do have
language query.
styles listed in the e-commerce, so
Ah,
it tells us if it's Y2K or vintage or that kind of thing. So we can
let's
try.
see how we go.
But maybe this is a good scenario. Actually, yeah, I think it might be a very good scenario in which we should have yeah. So here, as you can see, I've added a description for the price property specifically, but not a description on the category or subcategory, which, and I don't remember which one it was, but one of them, maybe no, one idea would have been to describe it as the category of the clothing item, as in whether it's vintage, sports clothing, what have you. Let's see what happened. All right. I do have a response, and it is under $200.
Wonder what query it ran.
Okay, actually, this is not bad. The category is not vintage.
Okay.
That's pretty good.
Yeah, that's pretty cool. So again, because I guess it's identified that there is a category
Yeah,
sorry, there's a property called category, which is, I guess,
yeah.
is a categorical variable. And it's gone, oh yeah, I'll just filter for things that's not vintage. Whereas I guess if it had to rely on like free text and do vector search, it probably would have struggled because embedding models don't do so well with negation.
So yeah, I guess the overall answer to that would be if the negation could be resolved with a simple filter, the agent will be able to generate that filter for you. So just so that you know, these queries are basically what the agent decides
Yeah.
that the agent generates to then run on Weaviate. Yeah, so I guess in this case for us, we're actually quite lucky that we have a lot of
Mm.
categories, and in this case, we could negate simply on the category.
Yeah.
Um, property.
And your price example there is a really good one, right? Because that is a negation, like that is a hard negation. You said your budget was $200 and it's gone, oh, I'll just only return results where the results had a dollar value less than 200. So it's able to do exactly that. Whereas some other things obviously a little bit fuzzier.
All right. Are there any other questions, or shall we start looking into the
Yeah,
system prompt?
not yet. So let's look at system prompts, which is cool.
So I think this is probably my favorite feature that was added to the query agent. The query agent by default is designed to answer queries based on contents of collections. However, you can provide it with a custom system prompt. And if you don't know what a system prompt is you can kind of imagine it as a way to provide a blueprint for your agent as to how it should behave effectively. So here you can be as creative as you want effectively. But what I've done is I've imagined up a scenario where we are creating a multilingual agent. So the contents of our collections are all in English in this case, but in my imaginary world, I'm thinking of a scenario where I may have users that speak different languages. And although the agent will perform searches and then it will get responses from the collections in English, I want it to be then answering the user in the user's own language. This is, straightforward yet complex task in a way. So I've provided the system prompt that reads the following. You're a helpful assistant that always generates the final response in the user's language. You may have to translate the user query to perform searches, but you must always respond in the to the user in their own language. This can become a bit of a trial and error. In my case, I did have situations before adding this last sentence here where the queries sent to our collections were also in a foreign language and not English, which then caused some issues. So I'm also letting the agent know that when it is generating queries for Weaviate, it should be translated into English, whatever the scenario. Hopefully this still works. We'll find out. And in this case, I've also decided to why not provide it with some more collections. So in this case, we don't only have the collections e-commerce and brands, we also have collections financial contracts and weather. I will definitely not be reading this out in French. This is not happening. But here is a question in French. That is asking for the average speed of wind, the minimum and the maximum speed of wind. We have a weather collection, so hopefully, if all goes well, and if it doesn't, again, we have a backup. We can have a look and see if it picked the right collection and perform the right, hopefully, aggregations. I'm simply printing out the final answer here. So I'm not doing the fancy search, but I will also, why not, do this response.
That was quick.
Dot display. Well, I think it's because it's mainly aggregations, which is why it's quick. And that's actually quite good. So, okay, it decided wind speed in the weather collection. Again, wind speed, but different metrics, minimum, maximum, mean, and there we have it. And then we have some more questions here that you can play around with. These are all questions about the brands, for example. Does Echo and Stitch have a brand in the UK? This was an interesting one for me because in this case, as far as I remember, the Echo and Stitch brand itself doesn't have a UK brand, but it does have a parent or child company that operates in the UK. So this was actually a tricky one. So in the end, yeah, let's see, or does it have a parent or child company that operates there? So we can have a look and see if that works well.
So is this us trying to one up the agent and see how well it does?
Yeah. Yes.
If it passes the test.
This is correct. For anyone interested, by the way, the brands collection is a fake brands collection. It was generated for the purposes of this recipe, so that's why I know so much about these brands, because I've looked at the data set so much. And yeah, I can tell you this is correct. There is Echo Stitch Active, Echo Stitch Kids. It does have a parent brand that operates in the UK, but itself does not operate in the UK, which is great. And yeah, so you can play around with this as well. And just to let everyone know here, so this recipe is out there in the wild for everyone to try out. This is definitely a preview service for now. So please play around with it and do please let us know what you think, how you get on, if you do have any feedback. We also have the agents category in the Weaviate forum now. So if you do have any questions or feedback about the query agent specifically, you can always drop that in the Weaviate forum and tag it with the agents category as well. Yeah, we'd love for everyone to try it out. Are there any more questions in the chat?
One just came in about GraphRag. So the question's from Rohini says, GraphRag gives us responses to different documents. Can we use this query agent instead of GraphRag to get responses from different documents that are laid out across different collections? It's an interesting one. So I guess
So
Rohini is asking about like identifying relationships between documents in a way.
in a way, yes. Um, you can use this to get answers on based on different documents and potentially also be able to infer relationships based on the properties they might share. I'm not going to say this is replacing GraphRag entirely because this is my understanding of GraphRag. GraphRag does something quite different in that it has graph representations and then community descriptions of that graph that basically is a cluster of documents, maybe a cluster of things that are relevant to each other that have some set of information. But for each of those clusters, we also have further summaries of what each of those sort of communities represent. So GraphRag is really good for that reason in answering general questions about what a whole thing might represent, which you don't get with classic RAG a lot of the time. With classic RAG, you can ask a direct question that then you can retrieve the context for and then answer that specific question for. But classic RAG doesn't always do great if you, for example, ask a question like, what do all of these reports talk about? Because that has to like have an overview of all of the reports that are maybe in your graph at this point. You could possibly actually resolve this by having collections that have really good descriptions, which may start to move in the direction of replacing GraphRag in that sense. But I don't think it's a one-to-one, so I don't want to give a solid yes answer to that.
Yeah, that's an interesting one. And in my understanding is that graph databases or whatnot do a good job of like letting you go from one reference to another. Whereas if you're using something like a Weaviate, you kind of maybe you can approach it a different way because our recommendation with data structure like that is to flatten out those kind of types of documents and just incorporate the references into the main doc, in which case I wonder if that'll be useful. Oh, there's a question which thank you for reminding me, which I neglected to ask because I'm an excellent moderator, which was, will this query agent help us to improve vector search results? What do you think?
I think it improves what vector search you actually do, but the vector search itself is the same vector search
Yeah.
ultimately. Oh, there are quite a few things given. Actually, this is, yeah, maybe I should have talked about that as well. A few things that I glossed over because I wanted to focus on the query agent itself. For this demo, we're using Weaviate embeddings. So we're using the Arctic embedding model, which is something you can enable in your Weaviate Cloud console. So that is the embedding model we're using. And at the end of the day, it's the same vector search that we would have manually run. What this improves is we don't have to think about exactly what query to run to get to our ultimate goal. That is the LLM's responsibility at this point. So in that case, maybe, yes, it can improve vector search because it's not just doing vector search. It may then also decide to get to the final answer, I need to do regular vector search on this collection and aggregation on that collection, and then provide an overall response for you.
Yeah, I think that's a great answer. Hey, because as you said earlier on, the strength, the interest, the cool thing about the query agent is that you ask it to go and do a thing as opposed to you implementing the syntax yourself. So if you say ask it to, find me nice vintage shoes under whatever amount of dollars, it'll go and perform all these searches because it kind of is the expert in knowing what searches to perform from Weaviate. So yeah, as you said, it won't necessarily improve the vector search because it is vector search is to vector search. But it'll do kind of like you're delegating a lot of your work to in essentially some expert to perform those searches. So yeah, that's really cool.
And with that, we actually have also another agent that we released for everyone to preview last week. That is the transformation agent, which is very different to the query agent, but it allows you to basically manage your Weaviate collections with the help of an LLM, where you can decide what kind of operations you want to do on your collection in natural language. So instead of having to design transformations from scratch yourself, you can simply write in human language, I would like a new property that summarizes something, and I want that to be added to all of my Weaviate objects. That is now available for everyone to preview as well. We released that last week. You can check it out already in the Weaviate blog. It also has a recipe for you to try out. It also has demo data sets that you can get started with. And we have another hands-on enablement session coming up for that next week, I believe. And it'll be the one and only JP leading that session, as far as I know.
Yeah.
So definitely join that as well.
Yeah, it's looking forward to that one. And the question earlier about negations and things like that, I'm kind of thinking whether we might potentially use the transformation agent to create let's say a Boolean variable like is vintage or not, something like that. And then if we run the query agent on top of the transform data, whether we might get better results. That'll be kind of an interesting one to see. But that's the sort of stuff we would be able to do with a transformation agent.
And I can tell you there is a Boolean property being created in that recipe.
Aha, there you go.
So there you
Spoilers.
go.
Cool. Okay, this is a perfect timing as well, just about on the hour. So, I don't know if anyone has any more questions. If you do, please do drop them in chat. But otherwise, big thank you for Tuana. Really appreciate it. It was a really good demo. Really appreciated watching it. Had a good time. And thanks everyone for hanging out. It was like a really good session and thank you for your questions as well.